Well, hi class. This video is going to help with 3-2, and now we're going to start having compound interest. So here's our formulas, but what is compound interest? The idea is you're gaining interest on your interest. So if I'm compounding every month I'll get a statement with my interest, and then the next month I start to gain interest on that interest they put in your account. Where simple was like, here's a specific amount at the end of a time period. So this could constantly be adding money to your account. This could also be paying money all the time, right? In a credit card or something like that. So we have a couple different things here. Let's see. So if I'm looking here, this is our simple interest from our last section. And this one is compound interest here. I want to write this out a little bit different. Your book teaches this with the letters a little different. I want to make sure you've seen both ways. So it's principal times 1 plus the rate divided by n to the power of n times t. Both those say the same thing. They call it M, I call it N. It's just a textbook difference. M represents the number of compounds you have in a year. So what if you compound monthly? Then you would have 12. Let's make a little list of these over here. So monthly is M is 12, or N, whatever way. Quarterly is going to be 4 times a year, every 3 months. That one's common. You'll see that in some of the tax stuff and things like that. It's paying quarterly. Yearly is just 1. So it throws people off because it's just 1. And we could see, monthly is 12. Let's see. Daily, 360 they usually use. Usually it's or 365, but it'll tell you 360 on the daily, and that's because they round each month to be the same 30 days. So that's where the 360 comes from, and you lose 5 days because some months have 31, some months have 28. So that's kind of where that comes from. So daily, I don't know. Weekly could be 52 weeks a year. So those are kind of the idea of M or N. Okay, both. So then we have this compound interest here, but it's missing the word continuous here. What if I wanted to compound it constantly, like every second of every minute of every day? Then it is this formula here, because this formula has this E, which is just a number like pi, 2.7 something, I believe. Anyway, it's on your calculator, and it just is basically rounding to compounding constantly. Okay. Last definition here is annual percentage rate. What if I have some option of some compound monthly, and then I have some option of compounded continuous? How do I know what's the better idea? The rates might not be the same. So that's where this annual yield comes in. It will basically tell you what is equal to 1 year of simple interest, so you can compare better. Okay. Or that's the idea. All right, let's look at some examples. And then our letters are still all the same. P's principal, R's rate, T's time, in years. Okay. Suppose that $3,000 is invested in an account paying 2% annual interest, which is about what a savings account has. Compare the balance after 20 years using simple and compound interest formulas. So it wants you to do it as both simple and compound. So simple comes from the section before. So we know that we would have A equals our principal times 1 plus the rate times time. And for this one, our future value is always A, would be $3,000 times 1 plus our rate of 2% times time, 20 years. Excuse me. So I'll calculate this out. 3,000 times 1 plus 0.02 times 20. Into my parenthesis, I get the future value is $4,200. So that's simple. Now let's do compounded continuous. I mean, not continuous. Compounded. I guess once a year. Oh, here it is. Compounded once a year. I was like, it has to tell you. Compounded yearly is once a year. So then we're going to have our new formula of A equals P times 1 plus the rate divided by, I'll use their M, which is fine. And then it's M times time. Okay, so then for here, the principal is still $3,000. We still have 1 plus. Now our interest rate is 2%, and we are dividing it by 1, which doesn't really change it because it's once a year. Up here, it's once a year times 20. Okay, so in your calculator, you got to make sure this is in a parenthesis, or it will not necessarily give you the right answer. I mean, you have a 1, so you could just put in 20, because 1 times 20 is 20. So I'm going to put in 3,000 and then a parenthesis, 1 plus 0.02 divided by 1, which isn't that big of a deal, divided by, in parenthesis, the 20 times whatever. It's just a 1, so it's a little bit easier. And it's going to be backward, but there we go. You get the idea. The graphing calculator. So our final answer here, $4,457.84 if I round. And you can definitely see the difference. I only compounded once a year. What if I compounded monthly or weekly, which is even better, or daily, which is even better, or continuous, which is even better? So then I would make more and more money. Okay. And it does ask how much more, so you could subtract those and get that if it asks something like that. Okay. The next problem, the point of this next problem is to show 4 different ideas: the semi-annually, quarterly, monthly, and continuous. So just to kind of show you what it looks like for 4 different of the same, almost the same thing. D is a little bit different. So A is going to say semi-annually, twice a year. And this time we have $6,000. I don't have a lot of room, so I'm just going to write the formula. A equals $6,000 times 1 plus my rate of 3% divided by 2, because it's semi-annually, and to the power of 2 times 10 for the years. Okay, I'm going to calculate this out. So 6,000 times 1 plus 0.03 divided by 2 into my parentheses, and I did a parenthesis for my exponent as well, and I got $8,081.13. Ooh, so in 10 years, I've gained a couple grand. That's not bad. And that one's only twice a year do they give us our interest to start gaining the interest. Okay, so part B is the same thing, but what do we change when we say quarterly? We change the 2, the semi-annually, to a 4. So it's the same idea, 6,000 times 1 plus 3%, but now we're going to divide by 4 for quarterly. Oops, it doesn't look like a times in between. 4 times 10 up there. Okay, so I'm going to hit secondhand enter on the graphing calculator, and then I can just go in and change the 2 to a 4 on a couple places here, because it's all the same, and I get $8,090.09. Okay, not a ton more money, but still more money, right? Okay, and it really does show like it's not that much more money. What is why I like this problem. So monthly. So you're going to then change your 6,000 times 1 plus your rate. Now it's divided by 12, right, to get that monthly. So I'm going to hit secondhand enter again. I'm just going to change my 4 to a 12. And so I'm going to do that in both places here. I have to do insert to insert one letter, but I get, ooh, it's even less on this one, $8,096.12. Okay, pause, make sure you can calculate this on your calculator, okay? So D is our first one that looks like compound continuously, which is P times E to the RT. So let's put in our values. P is still 6,000. E will be a key on the calculator. The rate is 3% times 10 years. So on this one, over above the log on the side, there we go. On this side over here above the ln, the log, you'll see the E to the X key. So what I'll do is hit 6,000, then I hit the E to the X key, and then I put in the 0.03 times 10. It automatically does the exponent part on there. And I get, with continuous, $8,099.15. There's like alarms going off in my ears as I'm trying to record. I'm like, what is this for? Okay, so I can look at these and it's really not that big of a difference between the four. Still a difference though. I mean, it's still money the bank's giving me, but it's not that big of a difference. Okay, problem 3 is like doing it slowly in a chart, and I don't know that you need help with that one. Okay, so let's see here. Definitely should do 4. I am saving for a down payment on a house, and I plan to buy the house in 5 years. How much would I need to invest right now that pays 3.5% compounded monthly in order to have 15,000 for your down payment? So on this one, we know A equals P times 1 plus the rate divided by the M to the M times T. So let's put in what we know. We know that we want to get to 15,000. So that is our future value. And we don't know what we want to have right now. So that's what we have to find, is that P. And then it's 1 plus our rate is 0.035. And it's monthly, so 12 times 5 years. Okay, so for this one, I can calculate out this section here, and that's times by P, and then divide it over. So I just need to calculate out in a parenthesis 1 plus 0.035 divided by 12 to the power of 12 times 5, making sure 12 times 5, either you do it before or it's in parentheses, and I get P times 1.19094. I'm going to leave that in the calculator so my rounding error doesn't become an issue. So then I'm going to put in 15,000 and say divide by my last answer, so I don't have to worry about the rounding, because this equals 15,000 here, and then you have to divide this over. Divide 1.19094-ish, and I get 12,595.06. If you go out, so we always are going usually either to the nearest dollar or we're going to the nearest cent. If you go out like 5 decimals, then you won't have the rounding error to get the problem wrong in my math lab. Excuse me. So send me the problem through the Ask the Instructor if something you're like, I swear I got this right, or something goes wrong there. Okay, so on this note packet, 5 is similar, 6 is similar. Where's one? Oh, nope, 6 is what I want to do. Okay, what if I'm asking for how long something takes? So anytime something asks for how long, I have to use a log to solve it. So 6 is harder. So we've done this in the warm up or the week that no, we didn't for this class. I'm thinking of business calc. I lied. Never mind. You're going to do it right now. Okay. We know A equals P times 1 plus a rate divided by M times T. So this says Joe inherited $6,000 and he would like to use the money for buying property. If he needs $7,000 for an investment, how long would he have to wait to buy his property? If he invests the money in an account that pays 3.3 compounded weekly. Okay, first of all, I don't know what property is $7,000, but I would like to move where that property price is. So our future is 7,000. Don't you agree? Okay, 6,000 here in Sheridan or Gillette. I think the prices are pretty high. So 6,000 is our future goals, or excuse me, 6,000 what we have now. 7,000 is that future goal. That's our A. And then we know 1 plus our rate is 0.035. Compounded weekly, there are 52 weeks in a year to the power of 52 times. Oh, we don't know. That's our point. I'm going to use a capital T. Otherwise, it looks like a plus sign, especially when I'm writing with my Apple pen. Okay, so how do I solve this? What I'm looking for is in the exponent. That makes it a lot harder. So what we're going to do is we're going to divide this over because it's times. Then we're going to simplify this, and then we're going to use a log. Okay, so divide the 6,000. So we always start here. So 7,000, I mean, it's 7,6. We can use the decimal, but it repeats forever. It's like 1.16666. So let's just leave that as 7,6. And that equals the 1. Oh, wait, let's calculate that out. What is 1 plus 0.035 divided by 52? I get, what did they used 1 point. How many decimals? They went out 6 decimals on the note packet. It's a decimal also. 1, 2, 3 zeros, 6, 7, 3, 0, 7, 7. Oh, that's ugly. Okay, to the 52 times t. Now, in order to get my t out of the exponent, I'm going to have to use a log. And the way that we did this, and you might remember this from algebra, you just may not, is we wrote log on both sides. And we always just use natural log, LN, because if we have an E, it's way easier. So just use log, natural log. So what we basically do is we write natural log of 7,6 equals natural log of 1.006730077 to the power of, I can write that as 52t, or I can keep the times there if I want. Whew. Whole reason I did a log was because what it does is it allows me to bring the exponent here down out front. So let me write that out. My copyright here is kind of in the way. So I would have our natural log of 7,6 equals log, oops. Okay, our 52t times natural log of 1.006730, whatever. Why do I ridiculously go out a bunch of decimals? I do it because I don't want you to miss a problem for rounding errors. And we need to be careful. So pretty cool. The log allowed me to bring that 52t out front. Now, this is just a number from the calculator. That's just a number from the calculator, and then 52. So calculate this, divide by this, then divide by this. So in my calculator, I hit natural log over here on the side. Then I put in 7 divided by 6 in the parenthesis for natural log. I get that answer. It's about 0.15. Then I'm going to hit divide by the other natural log. So natural log of 1.00673,077. And I get like 22.97 something. So here's where I'm at right now. Oops. 22.98, I guess, if I round it, is equal to 52t. Pause, try it in your calculator, make sure you can get that far. Then I divide by 52. So I do two separate divisions to get 0.44. Okay, let me try it again real quick. They got 4.4 instead of 0.44, so maybe I did something wrong. So natural log of 7 divided by 6 is this decimal divided by, I'll use a parenthesis, natural log of 1.00673,077 is 22, yeah, divided by 52. I don't know, I got 0.44 for time. Is my decimal off when I put it in? I don't think so. No, because I got that same answer. Yeah, I'm not sure where they got that. I would just go with 0.44 years. I don't know. The answer key is always wrong, so maybe I shouldn't even be looking at it. Okay, we're good. Maybe you will see my error. I don't know. Okay, problem 7. So we can use that log, and it's not hard. You basically just write the log in, right? So you just write the log in front, and that allows us to bring the exponent out front, and then you're just doing division. It's not like a hard process, but you definitely have to see it to be able to get that log idea in your head. Okay, I have a separate video for one of these problems. I think it's in this section. Let's see, so 21st birthday. I think the rest are pretty similar. Problem 8 says like Robert invests 15,000 in 9-month certificate deposit. And it is a compounded monthly. You know, most CDs are simple, but that's okay. At the end of the 9 months, he moves that money plus the interest he earned into another one. So basically, you have to calculate the first one, get your answer, and use that amount to put it into the next one. Is one way. The way they do it here too is you could also, well, add them together. I would calculate the first one. Let's just do that one. I don't care. We have plenty of. Let's just do this one. Okay, so the first one is 15,000. I don't have a ton of room, so I'm just going to write the formula. And it is at 1 plus 0.042 divided by monthly. So 12. To the 12 times, we have to use a fraction, 9/12, because it's not a full year, right? 9/12 is how many months, and 9/12 times 12 is 9, so that's a little bit easier. So I'm going to calculate this out. So boop, boop, 1,500, what in parentheses 1 plus 0.042 divided by 12 to the power of basically just 9, because 9/12 times 12, we just said that. So I get $15,047.92. Okay, at the end of the 9 months, he moves the money plus the interest he earned to another one for 6 months at 4.5, excuse me. So his new one would then have that principal of $1,547.92, and it's at 0.045, and it's compounded monthly, and it is for 6 out of 12 months, or 1/2, right? Okay, so I'm going to use that number, 1547.92, And then I'm going to times it by 1 plus 0.045 divided by 12 to the power of, now 6 12ths times 12 is 6. So to the power of 6, and I get a final answer of 1583.8 cents. Now, they did it a completely different way and they got the same answer. This to me is the easiest way. I don't really like their method. So the example button might be a little weird if you look at the example for one like that. Oh, I almost forgot number 9. Okay. All right. By comparing the APY, the annual percentage yield, decide which is a better investment: 4.26 compounded monthly, an interest or an investment at 4.3 compounded quarterly, and the last one 4.38 compounded semi-annually. I have no idea. They're all so similar that we have to use our formula for this. So remember, our formula goes like this. It's just 1 plus R divided by M to the power of M minus 1. That's it. That's our formula. And all this does is it makes it to where they're all like a simple rate so we can compare them. So for the first one, and this is compounded monthly, we would have 1 plus 0.0426 divided by monthly to the power of monthly minus 1. Get out my calculator, parenthesis 1 plus 0.0426 divided by 12 to the power of 12 minus 1 is going to give me 0.043-ish. Okay, what percent is that? Move the decimal 2 places, that's 4.3%. Okay, it'll always give you the decimal and you have to write it as the percent. Okay, the next one we had was compounded quarterly at 4.3. So 4.043 is the rate as a rate as a decimal. And then this one was quarterly, which is 4 to the power of 4 minus 1. So I'm going to put it in my calculator, 1 plus 0.043 divided by 4 to the power of 4. Oops, I forgot it. I didn't quite enter mine in right. Okay, there we go. And then we minus 1. I get 0.0436. So, or 7, this would really be a 7. And so this is 4.37%. Maybe I should have gone out a little bit more further on this first one, but either way. Okay, then the next one would be 1 plus 0.0438 for the 4.38% compounded semi-annually, twice a year is 2. So 2 minus 1, so 1 parentheses 1 plus 0.0438 divided by 2 to the power of 2 minus 1 is 0.0443. So 4.43. Okay, there we go. Now, see how that made it a simple interest, and it shows you what the rate would be. So here's our 3 answers, what the rate would be for each situation. Which one's the highest number? Last one. So this is our winner. So the best option is 4.38 compounded semi-annually. So really, we want the highest rate, and rate plays a huge role, and the most compounds. Okay, but rate plays the biggest role by far in how much money you will gain. Okay. 10 is another APY one. Rate. The rest are fairly easy, or I mean, there's something we've already done, so I think we're good. All right, let me know if you have any questions on this homework. If I'd stop coughing and be able to stop the recording.